Hi guys, today let's discuss the LeetCode question 235, lowest common ancestor of a binary search tree. Given a binary search tree, find the lowest common ancestor node of two given nodes in the BST. According to the definition of LC on Wikipedia, the lowest common ancestor is defined between two nodes P and Q as the lowest node in the tree that has both P and Q as descendants, where we allow a node to be a descendant of itself. Let's go to the constraint section as well before going to the examples. So in the constraint section we have there will be the lowest range for the number of nodes in the tree is 2 and the max range is 10 to the power of 5. The reason for the lower range being 2 is because P not equal to Q, that is a fourth constraint, and P and Q will exist in the BST, so which means that at least there should be two nodes in the tree. That is the reason why the number of nodes in the tree is between 2 and 10 to the power of 5. And all the node values are unique and the values of node values are between this range. Okay, let's go to the example since the constraint is clear. So in the example 1, the value of P is equal to 2 and Q equal to 8. So 2 is here and 8 is here. The lowest common ancestor for these two nodes is 6, since 6 is the parent for 2 and 8. Let's go to the example 2. The value of P is equal to 2 and Q equal to 4. So the output is going to be this 2 node, since a node can be a descendant of itself. So this is the answer, like the output is 2. Let's go to the example 3. So the value of P is equal to 2 and Q equal to 1 and the output is 2. So this is going to be the root node. Okay. I hope it is very clear from this question description. Let's go into the explanation part of it. Let's look at the case 1. In this given binary search tree, the value of P and Q is 2 and 1. So if we look at the 2 and 1 in this binary search tree, they are occurring in the left subtree of this binary search tree. So what are we going to do in this case? We are going to recurse left. Let's look at the case 2. In this case 2, the value of P and Q in this binary search tree is going to be 6 and 5. So these 6 and 5 are occurring on the right subtree of this binary search tree. So in this case, we are going to recurse right. Okay, let's recurse right. Let's look at the case 3. There are 3 scenarios in the case 3. In the first one, the value of P and Q is 2 and 6. In this case, our output is going to be 4. This is the lowest common ancestor. And let's look at the example 2. So the value of P and Q is going to be 4 and 2. In this case also, the value of the lowest common ancestor is going to be 4. And let's look at the example 3 in the case 3. So the value of P and Q is going to be 4 and 6. In this case also, the value of the lowest common ancestor is going to be 4. So for the entire case 3, we are going to return root. Okay. So let me reiterate all the 3 steps again. So whenever the value of P and Q are occurring on the left subtree of the binary search tree, then recurse left. Whenever the value of P and Q are occurring on the right subtree of the binary search tree, then recurse right. In all other cases, you return the root. So I hope it is clear from this explanation. So let's quickly code this up. Let's start by considering case 1. So case 1 is if p.val is less than root.val and q.val is less than root.val. So in this case, we should recurse towards the left. So return self dot lowest common ancestor of root dot left comma p comma q. Now let's consider the case 2 where the value of p and q are greater than root dot val. So this is an else if condition. P dot val is greater than root dot val and q dot val is greater than root dot val. So in this case we are going to recurse towards the right. So self dot lowest common ancestor of root dot right comma p comma q. In all other cases we are going to return root. I hope we are done. Let's quickly run the code. Yeah, let's quickly submit it as well. Yeah, it is submitted. Hope you like the explanation. For more such videos, please subscribe to my channel. Thank you.